Example 1, find the integral of sine cubed x times cos x with respect to x. So this looks pretty complicated, but if we use a substitution, we can simplify this. We're going to let our substitution be u equals sine x. So we choose a letter, and it's usually u, to replace one of the complicated looking parts of the integral. Now, the reason I've chosen sine x instead of cos x is because it's the sine x that is cubed. So when we go to replace things inside this integral or substitute things, instead of saying sine cubed x, we can just say u cubed. After you've decided what you want u to be, the next thing you should do is differentiate it. So du dx, which in this case would just be cos x. The reason we need to do that is because we also need to replace the dx in the integral. So we're going to rearrange this expression to make dx the subject, and that will be du over cos x. It might feel a little bit weird splitting up the du dx like that the first time you do it, but it is allowed. We can then go back to the integral and see that we've got u cubed times cos x times dx, which we're now going to replace with du over cos x. And a lot of the time in integration by substitution, things will cancel out. So for example here, the cos x and the cos x cancel, which is good. Now we're left with just u cubed to integrate with respect to u. That is going to be 1/4 u to the power of 4 plus c. And then with integration by substitution, make sure you replace your u in the end with the original function in terms of x again. So that will be 1/4 sine to the power of 4 x plus c. And that's it. Example 2, show that the integral between 1 and 2 of x over x plus 4 dx is equal to 1 plus 4 ln 5 over 6. So for this one, we can simplify the integral if we let u be equal to x plus 4. That way, the denominator in the fraction is just going to be u now. Once we've chosen what u should be, let's do du dx, which in this case is nice and easy, just 1. So if we rearrange for dx, we just get 1 du or just du. So that means we've now got something over u du. All that's left to do is to replace the x if we can. Now, because u equals x plus 4, you can rearrange that and say that x is in fact u take away 4. That way, you can replace the x on the numerator there with u take away 4. This can then be split up like this, so u over u minus 4 over u, which is just the same as 1 minus 4 over u du. Much easier to integrate now. Now for this example, notice that we're given limits. So we were given limits of 2 and 1, but these are actually x limits because they came with the integral that was with respect to x. So we need to change them to make sure that they're u limits. To do that, you just need to substitute into the u equals x plus 4. So for the 2, it will just be 2 plus 4 or 6. And for the 1, 1 plus 4 or 5. And those will be the u limits here. We can then go ahead and actually integrate this. That would be u take away 4 ln u with the limits of 5 and 6. And then we just evaluate this integral as we normally do. So that will be 6 minus 4 ln 6 minus 5 minus 4 ln 5. If you tidy this up, you get 1 minus 4 ln 6 plus 4 ln 5, which then if we think about our log laws will simplify to 1 plus 4 ln 5 over 6 as required. And that's it. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks and see you next time.